So today I will discuss thermodynamic systems and surroundings. What is actually thermodynamics? Thermodynamics. So actually the thermodynamics deals with the thermo and dynamics. Dynamics means that is motion, and thermo that is a heat. So here the thermodynamics is the science of energy transfer or heat transfer to the other energy forms. That is called a thermodynamics. So actually the thermodynamics is very important for engineers which are involved in power generation and process industries. Actually the thermodynamics, the flow of energy or the study of flow of energy is very important. So also the thermodynamics helps us to understand the nature or the degree of energy transformation. So anyway, today I will discuss about the what is system and surroundings. What is thermodynamics, system and surroundings? What is a actually system? So anything in universe is under study. Each system or any portion of universe is under thermodynamic study. Thermodynamic study or observation is called system. It's called system. For example, suppose a cup of tea, a hot cup of tea is a system. A cold water, a glass containing cold water is also a system. So here study about this hot cup of tea. What happens to the hot cup of tea or tea containing inside the cup after time passes? So that hot cup of tea is called the system. This hot cup of tea is called the system, and the parts which are not the part of system or area outside the system is called surrounding. So area outside the system is called surrounding. So this hot cup of tea is system. This is system, and outside area which are not the part of the system is surrounding or area outside the system is surroundings. So here the wall which separates the system from the surrounding, is called boundary. So boundary may be real or imaginary. So in this hot cup of tea, this wall of the tea cup is called real boundary. So in this top surface of the cup, there is no actual boundary is there. In this top surface of the cup, there is no actual boundary is there, but a system has a boundary, and that boundary is called imaginary boundary. So that boundary is called imaginary boundary. There is no real wall on the top of the cup, but a system, and this system has a boundary. So that boundary is called imaginary boundary. Also this boundary may be fixed or movable. So in this hot cup of tea, this wall or this boundary cannot move in this direction with respect to the other one. So that is our fixed boundary. So similarly, what is the movable boundary? For example, a piston cylinder arrangement. The piston contains gas here. So here this piston can move up and down the piston can move up and down. So this boundary is called the movable boundary, and these boundaries cannot move with respect to each other in this direction or in this direction. That boundary is called our fixed boundary. So now I'll discuss about the system, types of system. So for example, a piston cylinder arrangement, the cylinder contains gas here, here the system, this is a system, and outside is our surroundings. So what is the interaction between the system and surroundings? So what are the interaction, what is the chances of interaction between the surrounding and system, or system and surroundings? So definitely, so heat can move from the system to the surrounding, or heat can move from the surrounding to the system. So that is our first interaction. There may be a chances of heat interaction from the system to the surrounding to the system, and from the system to the surrounding. So for example, that hot cup of tea, so after some time from the heat will dissipates to the surroundings. So that is definitely heat will out. In case of a cold glass containing here cold water, so temperature outside temperature is more than this temperature of cold water definitely. So at that situation heat will transfer from the surrounding to the system. So in this case also heat can flow from the surrounding to the system, or from the system to the surroundings. So heat can in and heat can out. So similarly here another interaction, suppose the piston will move up and down. So piston can move up and down, so there may be a chances of work transfer here. So when the piston will move up, definitely volume will increase. So definitely at that situation we can call that work is done by the system, or when the piston will move downwards, the volume will decrease. So definitely at that situation we can call work is done by the surrounding. So in this system and surrounding there may be chances of work transfers. Also suppose if there is opening here or some passage here for the mass flow, so here the gas, we can add some gas to inside the cylinder, or we can remove some gas from the cylinder. So that is called our mass transfer, or that is also called the matter or mass transfer. So mass can flow from the surrounding to the system, and from system to the surrounding. So that is our mass transfer. So now what are the interactions here? So first interaction is our heat interaction. Second is our work interaction. Third one is our mass interaction. So now these three interactions are possible between the system and surroundings. So now according to the interaction, according to these three interactions, we can classify the types of system. So first system, that is our open system. So what is actually the open system? If these three interactions are possible in a system, or these three interactions are there between the system and surrounding, that is called our open system. So actually, for example, in every engineering or any engineering devices are open system. For example, air compressor. In air compressor, air enters at low pressure and leaves at high pressure, and also there is energy transfer is there. So that is called our open system. So in case of open system, simply suppose this is a system So energy can in and energy can out. There is energy system, energy transfer between the system and surrounding. Also there is mass transfer to the system and surrounding. So there is mass interaction and energy interaction is there in case of open system. So second case, that is our closed system. Closed system. So in case of closed system, what happens? There is no chances of mass interaction. There is no chances of mass interaction. Only heat and work interaction is there. Suppose in this piston cylinder arrangement, there is no passage for mass transfer. There is no transfer for mass flow from outside or from the surrounding to the system and from the system to the surrounding. So at that situation we can call that is closed system. For the closed system, only heat interaction and work interaction is there, because the piston can move up and down. Heat transfer and work transfer is there, and there is no mass transfer. That is our closed system. In case of closed system, so only energy can transfer from the system to the surrounding, but there is no mass transfer. So at that situation, inside the system, mass is fixed. Inside the system, here gas is fixed. There is no gas transfer from the surrounding to the system and from the system to the surrounding. So that is called our closed system. Or here the mass is fixed. So the closed system is also called control mass. That is called control mass. And third one is our isolated system. In case of isolated system, so in case of isolated system, all three interactions are not at all possible. Heat interaction, work interaction and mass interaction. All the three interactions are not at all possible for a system. That system is called isolated system. In case of a isolated system, suppose in this piston cylinder arrangement, these walls of cylinders are isolated from the surroundings. So there is no chance of heat transfer. Also there is no passage for mass flow. So mass flow is also not possible. Also suppose this piston is rigidly fixed with the other boundary. So there is no movement of piston up and down, hence there is no work transfer also. So in this case, that we can call that is isolated system. In case of isolated system, here energy is also fixed, also the mass is fixed. There is no transfer of energy and mass. In case of isolated system, there is no energy transfer, no mass transfer. So that is called isolated system. Thank you.